Hi students, welcome to today's class. Today I am going to explain. Yesterday I explained about what is left hand side limit and right hand side limit of a function defined at a certain number, some x is equal to a. So in this video I am taking a good number of problems. Generally majority of the students do mistakes while solving those type of problems. Okay. So let us start without wasting our time. So let us start our class. The first problem of today's problem is limit extends to 5 pi by 4 step of sin x plus cos x. So this is a greatest integer function. Then how to do this problem? So to find the limit of a function, at as x tends to a, that means here x approaches to a, not exactly x is equal to a, then it should be noted that it's both a left hand side limit, that is a limit extends to a minus f of x, and a right hand side limit extends to a plus f of x. Both should exist. First of all, both the limits should exist, and the first condition. And the second condition is those values should be equal. LHL is equal to RHL. Both the values are equal. Then only we can conclude that limit extends to a f of x exists. Understood? So whatever may be the value you get here and here, that will be the final answer for you. So this is the basic concept behind the limit extends to a f of x. Now coming to the problem here, so here see here, as limit x value approaches to 5 pi by 4, see the function step of sin x plus cos x. This sin x plus cos x, make it as a single function, single trigonometric function, either sin or cos. Generally we did this type of many problems we did. So multiply with the root 2, so this is a sin x into 1 by root 2, cos x into 1 by root 2. So this is a limit extends to 5 pi by 4 step root 2 into, so this is a sin a cos pi by 4 plus cos a into sin pi by 4. So we know that this is sin of x plus pi by 4. Understand? This is step. Okay. So two trigonometric equations I am able to successfully write it as a single trigonometric function, that is sin of x plus pi by 4. Now let us find out left hand side limit, that is a limit extends to 5 pi by 4 minus, limit extends to 5 pi by 4 minus. Now then what you will get here? So this is a root into sin of x plus pi by 4, this value I am going to find out. Now substitute x, you can write it as a h tends to 0. So here in place of x, h minus 5 pi by 4, like that you can write it as, we can write. Okay. So let us write this as a limit extends to 5 pi by 4 minus, so substitute there. So just directly you substitute here. So step of root 2 into sin of 5 pi by 4 plus pi by 4. Okay, this is step of root 2 into sin of 5 pi by 4 plus pi by 4, 6 pi by 4, 6 pi by 4 means 3 pi by 2, sin of 3 pi by 2. So this is a root 2 into, this is a minus 1, this is a minus root 2 means minus 1.414. This is equal to minus 2, step of minus 1.414 is equal to minus 2. Similarly, let us find out the value of RHL, limit extends to 5 pi by 4 plus, this is equal to root 2 into sin of x plus pi by 4. So we can proceed like this. So here we are approaching here minus 3 sin of 3 pi by 2, here we are approaching x to 5 pi by 4 from right direction. Here also you will get here, so root 2 into sin of 3 pi by 2. So this is equal to root 2 into minus root 2, that is equal to minus 2. Okay. In both the cases, left hand side limit and right hand side limit, we got minus 2, therefore its value is equal to minus 2. Understand this? So very interesting problem this is. I hope that you understand this solution. So I am going to now explain a very, very interesting problem. Let us see that. Hi students, welcome to this one of the variety problem here. Here one graph is given. So x-axis, y-axis, on x-axis 1, 2, 3, 4, 5, 6 and on y-axis 1, 2, 3, 4 is there. There is a function is there whose graph is this. That means the function is defined from 0 to 1 as a linear function. At exactly x is equal to 1, the function is not defined. The function is not defined. Understand here? So this means a gap. There is a gap. From 1 to 2, it is defined. From 1 to 2, the function is defined as a 3. That means the functional value is 3. But exactly at 2, the functional value is 2. From exactly at 2, the functional value is 2. And from 2 and 3, the function is defined as a 3. From 2 and 3, it is defined as a 3. But at exactly 3, the function is not defined. At exactly 3, the function is not defined. But for 3 left hand side and right hand side, it is defined. But x is equal to 2, left hand side, right hand side is defined. And at x is equal to 2 is also defined. But here x is equal to 1, left hand side and right hand side both is defined. Left hand side is defined and right hand side is also defined. Now let us see the statements here. Here 4 statements are given. Which of the following is correct statement? That we have to tell. The first one, limit x tends to 1 f of x does not exist. He is saying limit x tends to 1 f of x does not exist. Let us see here. Limit, so for first option A, so I am taking like this. LHL I will take, left hand side limit. LHL is equal to limit x tends to 1 minus f of x. Limit x tends to 1 minus f of x means what? The function from 1, this minus, this is defined like this. So here somewhere less than 2. So here something. So something. So x less, so the function is defined something different. Okay, now, so this is equal to something value less than 2, let us call it as a 1.9. It is defined like this. RHL, right hand side limit. So limit x tends to 1 plus f of x. 1 plus means what here? Here the function is defined as 3. The function is defined as 3. So if you are approaching 1 from right side, see the function is defined as a 3. So the left hand side limit is something less than 2, something less than 2, not exactly 2, but exactly 1 it is not defined, something less. RHL is 3. Therefore, both are not equal. Therefore, limit x tends to 2 f of x does not exist is correct answer. Okay, it is a correct. Now, second option, limit x tends to 2 f of x does not exist, he is saying. See here left hand side limit, that is equal to limit x tends to 2 minus. So 2 minus means what? You are approaching 2 from left hand side. See here, if you approach the 2 left hand side, what is the value here? 3. So f of x is equal to 3 you are getting. From right hand side limit RHL, limit x tends to 2 plus f of x is equal to, if you approach here right side, so this is equal to 3. So LHL is equal to RHL. Okay now, so LHL is equal to RHL. Therefore, the limit exists at x is equal to 2 exists, but he is saying he does not exist. So this is a wrong statement. Now see at x is equal to 3. Limit x tends to 3, f of x is equal to 3, he is saying. That means left hand side limit is 3, right hand side limit is also 3. So if you observe here, exactly at x is equal to 3, left hand side limit is also 3, right hand so. So LHL value is also 3, RHL value is also 3. Therefore, this statement is right. Now let us see here, limit x tends to 1.99. 1.99 means where? So here it is 1.99. 1.99. Okay. Limit x tends to 1.99 f of x exists. Yes, right. Why? Because 1.99 means, so see here. So here it, for left hand side it is 3, right hand side is also 3. Therefore, it is a exist, its value is 3. Therefore, D option is also correct. Okay, very nice problem. So we have to observe here left hand side and the right hand side limit. So here 1.9 means here. So here if you see here, so from left hand side 3, right hand side is also 3. So the limit exists and its value is 3. Okay, na? So very graphical problem. So I hope that you understand this solution. So let us move to next problem. Hi students, welcome to this problem. So limit extends to 0, x plus 4 by 2 minus x whole to the power of x square plus 2x minus 3 upon x plus 1. So when such type of problems are given, so don't think overthink, don't overthink. Okay, so we have a properties here, limit extends to a f of x to the power of g of x, same as limit extends to a f of x whole to the power of limit extends to a g of x. That means we can apply the limit both for the base and for the power. For both we can apply. So here also apply the same thing. So limit extends to 0, x plus 4 by 2 minus x. Here limit extends to 0, x square plus 2x minus 3 upon x minus 1. So here x will get cancelled. So x will 0, 4 by 2 is equal to how much? 2. So here also 0, 0, 0, minus 3 by minus 1. It is 3. 2 cube is equal to how much? 8. So 8 is the perfect answer. Okay, now. So very easy problem. So I hope that you understand this solution. Now we are going to see a very important basic concept. So it is not problem, basic concept I am going to explain. Let us see that concept. Okay. Hi students, welcome to this very basic fundamental concept. See here. If limit extends to a f of x plus g of x exists, if the function is exist, it is a sum of two functions, limit extends to a exist, then we have the following two cases. What are the two cases? Means limit extends to a f of x exist and limit extends to a g of x exist. Both separately exist and both separately may not exist. Both separately may not exist. Let us see this. Let us see this proof of this, very easy to prove. So let us the function g is equal to f plus g minus f. Can we write it as a function? G of x is equal to f of x plus g of x minus f of x. Now you apply the limit on extends to a on both sides. G of x is equal to limit extends to a f of x plus g of x minus limit extends to a f of x. Understand this? See here, this we have, this means limit extends to a f of x plus limit extends to a g of x minus limit extends to a f of x. So both will get cancelled. We got limit extends to a g of x is equal to limit extends to a g of x. So from this means what? If f of x plus g of x exists, then limit extends to a f of x exists and limit extends to a g of x exists. Both separately exist. Understand this? Right. Now coming to the second one, both limit extends to f of x and limit extends to d of x does not exist. For this, we can take a very best example. See here, limit extends to 1, that is step of x, it does not exist. So this is a greatest integer function, it does not exist. Like that, limit extends to 1, fractional part function also does not exist. We know that left hand side limit, right hand side limit, definitely it varies. It also does not exist. So here also rational left hand side limit x, this is from 1, left hand side you will get a 0, for right side you will get 1.1. So left hand side limit, right hand side limit both are not equal, therefore it is also does not exist, that is also does not exist. See there some limit extends to 1, fraction. So this is equal to limit, see this is ordinary bracket. So limit extends to n, step of x plus its a fractional part. So we know that it is a limit extends to 1, this is a x. So this is equal to 1, limit extends to 1, x is equal to 1. Understand this? Okay. So from this we can say if it is a exist, both may exist, both may not exist. Okay, now right. So I hope that you understand this concept. Hi students, welcome to this very important concept here. See here, limit extends to a f of x into g of x exists, f of x into g of x exists. Then we have the following cases. Both limit extends to a and the limit extends to g of x, f of x both exist. Second one, limit extends to a f of x exists and limit extends to a g of does not exist. Then also this happens. If both does not exist, both limits f of x, g of does not exist, but limit extends to a f of x, g of x exist. Let us see one by one. Limit extends to a f of x and limit extends to a exist means then obviously limit extends to a f of x into g of x exist. There is no doubt in it. For example, simple example, limit extends to a limit extends to 2 square, how much? 4. Limit extends to 2, x plus 1 is equal to how much? This is equal to 2. See the product, limit extends to 2, x square into x plus 1. This also exists, 2 square, 4 2s are 8. This limit is also exists. There is no doubt in it. That means if limit extends to a f of x exists, limit extends to a g of x exists, then limit extends to a f of x into g of x exists. Understand this? Right. So this is a very nice. Limit extends to a f of x exists and the limit extends to a g of x does not exist. The first limit exists, second limit does not exist, but the product exists. See the example. To prove this, let us take one example here. Limit extends to x square minus 4. How much this is? 2 square 4, 4 minus 4. This is equal to 0. The limit exists. Okay, now. See here, limit extends to 2, x square plus x minus 2 square 4, 4 plus 2 6, 6 minus 6 0, 1 by 0. Limit does not exist. Limit does not exist. Now let us see the product. Let us see the product of these two functions. So limit extends to 2, x square minus 4 by x square plus x minus 6. Let us see the product. So this is f of x and it is g of x. Now see the product. So this is equal to limit extends to 2, x plus 2 into x minus 2 by denominator x minus 2 into x plus 3. Denominator x minus 2 into x plus 3. So this x minus 2 cancel, it extends to 2. Substitute 2 plus 2 4, 4 by 5. So 4 by 5 is the right answer. So here the first limit does not exist, second limit does not exist. Understand this? But their product is exist. Now let us see the third example. So here you see here both, even though both the limits does not exist, f of x into g of x is exist. Further, let us take one example. F of x is a function defined as when x less than or equal to 0, 1. When x greater than 0, it is defined as 2. G of x is another function when x less than or equal to 0, it is defined as a 2. If x greater than 0, it is defined as 1. So there are two functions. Clearly, at x is equal to 0, the left hand side limit is 1, right hand side limit is 2. Therefore, it does not exist. Here also at x is equal to 0, the left hand side limit is 2, right hand side limit is 1, 2 is not equal to 1. It is also not possible. So both the limits separately does not exist. Then what is f of x into g of x? This value is 2. F of x into g of x value. So 1 to 2, 2 to 1. So the f of x into g of x value you will get 2. Therefore, limit extends to 0. F of x into g of x value is 2. So separately they does not exist, but their product exists. Understand? So I hope that you understand both the concepts. So basing on this, Let us do some problems. Hi students, welcome to this problem. See here, limit x tends to 0, step of x into e power 1 by x minus 1 by e power 1 upon x plus 1. Generally students will start doing like this. X tends to 0 means they will substitute wherever x is there, substitute they will put 0, here also 0, here also 0. Therefore, step of 0 is 0, therefore total answer is 0. Like that they will keep like the answer 0, but it is wrong. Those who have the subject command conceptual understanding, so don't do the problem like that. So whenever you have to find out limit extends to something, so you have to find out left hand side limit and right hand side limit. If both the limit exist, then only this function will exist. That means both this function should exist and this function exist, then only both the product will be exist. Okay, let us see the left hand side limit and the right hand side limit. See here, LHL left, limit x tends to 0 left minus, this is equal to some f of x, we call it as some f of x, total function we call it as f of x. This we convert it into h, infinitesimal definition. That is a limit h tends to 0, f of, so 0 minus h, f of what you have to write down? 0 minus h you have to write down. So that is equal to limit h tends to 0, f of minus h. Limit h tends to 0, f of minus h. Now substitute here. So therefore, limit h tends to 0, f of minus h means what? Wherever x is there, substitute minus h. So this is equal to minus h e to the power of 1 by, in place of x we have substituted minus h minus 1 by e to the power of 1 by minus h minus 1. So let us see the problem here. Limit h tends to 0, that means here you are approaching 0 from which side, which direction you are approaching? You are approaching 0 from left direction. So from left hand side you are approaching. Limit h tends to 0, step of minus h will be, then how much this will be there? So this we are step of minus h you will have, then we will, as x tends to h value approaches to 0, as x tends to 0 we are approaching left hand side. So here what we will get here? So this is equal to 0.1. So this is a minus 0.1 minus 0.99 minus 0.999, like that it will come. Understand this? Minus 0.999 means how much? Minus 0.99, step of minus 0.99 means minus 1. We know that step of minus 0.999 means how much? Minus 1. Okay, put it like that. Now see here, as h value approaches to 0, see here we can write it as one more step, otherwise e power, so this is 1 by minus h, so this is equal to 1 by e power 1 by h minus 1 by e power 1 by h minus 1. Understand? Sorry, denominator plus 1. As h value approaches to 0, this total e power 1 by h, as h value approaches to 0, 1 by h approaches to infinity. So e to the power of infinity, that means the denominator is going on increasing. Therefore 1 by this infinity, that means the denominator going on increasing, 1 by denominator going on increasing means it will become 0. So this is equal to minus 1 into, so this is a 0 minus 1 by 0 plus 1, so we are getting 1. The left hand side limit we got 1. Let us check the right hand side limit. So the right hand side limit is equal to limit x tends to 0 plus f of x. This is equal to limit x tends to, so we are putting here h tends to 0, f of 0 plus h, that is limit h tends to 0, f of h. This is right hand side limit. Now substitute here, limit h tends to 0, f of h means what? H substitute. So this is equal to step of h e power 1 by h minus 1 by e power 1 by h plus 1. So, one more step I will write down, limit h tends to 0, step of h into 1 minus e power minus 1 by h, 1 plus e power minus 1 by h. See here, as h tends to 0, you are approaching 0 from right side. You are approaching 0 from right side means what? So, this will be how much here? So, this is a 0.5, 0.6, 0.9, like that you will get. So, this you limit h tends to 0, we are approaching. So, this is 0.1, 0.2, 0.c. So, we are approaching h from right side direction, from 0 to that side direction we are getting. So, then limit h tends to 0, step of h value will be how much? 0. 0. So, we are direct means step of 0.5 is equal to how much? 0. Okay. But do not conclude that 0 into anything is 0, not like that. So, this should be a finite answer. As well we explained here, 1 by e to the power of 1 by h will come, the denominator goes on increasing. So, this will be 1 minus 0 by 1 plus 0, 0 into 1. So, this is equal to 0. See here, the left hand side limit is equal to 1, the right hand side limit is equal to 0, both limits are not equal. Therefore, this limit does not exist. This limit does not exist. Okay, now? So, this is called conceptually doing the problem. So, the vague sense generally students they will start x is equal to 0, e power 1 by 0, e to the power of infinity. So, therefore, e to the power of infinity means they consider it as a 0, 0 minus 1 by 0 plus 1. Minus 1, 0 into minus 1, 0. Therefore, they will conclude that the answer is 0. So, you should not do like that. So, you have to find out left hand side limit, right hand side limit separately, then see the product, then you see the answer. Understand? So, I hope that you understand this problem. Let us see one more problem. Hi students, welcome to this problem. If a1 is equal to 1, so in a series the first term is 1 and the n plus 1th term of that series is 4 plus 3an by 3 plus 2an, where n greater than or equal to 1. And it is one more thing is given, limit n tends to infinity, an is equal to a, then the value of a is. Okay, now see here, see the solution. Here it is given that n plus 1th term as a 4 plus 3an by 3 plus 2an. Let us apply limit n tends to infinity on both sides. That is limit n tends to infinity, an plus 1 is equal to limit n tends to infinity 4 plus 3an by 3 plus 2an. Okay, now? See here, limit n tends to infinity, an is equal to 0. See here, limit n tends to infinity, an is equal to a. Then limit n tends to infinity, a of n plus 1 is also a. See here, as n value goes on increasing, nth term is equal to a. So, therefore, n plus 1th term is also a. N plus 1th term is also a. So, the meaning of this, as n value goes on increasing, an approaches to a. Of course, an plus 1 is also approaches to a. An next number is what? An plus 1, that also approaches to a. So, this is the point you have to remember. So, this value is a. Now, we will apply the properties of limits here. So, we can apply limit n tends to infinity for first term, second term, down also we can apply. 4 plus 3 into limit n tends to infinity, an by 3 plus 2 into limit n tends to infinity, an. So, this is equal to a is equal to 4 plus 3a by 3 plus 2a. Why? Because limit n tends to infinity, an is equal to a. Okay, now? So, let us do the cross multiplication here. 3a is equal to 3a plus 2a square is equal to 4 plus 3a. Since a is not equal to 0, here a1 is equal to 1, no, a1 is equal to 1. So, then since a cannot be equal to 0, we can cancel. 2a square is equal to 4, a square is equal to 2, a is equal to root 2. So, a cannot be minus root 2. So why? Because here you check here for any value of a, n is cannot be -2. Therefore, a is equal to √2 is the correct answer. I hope that you understand this solution and you enjoyed today's class with some more basic concept and basic formulas. Tomorrow's class I will explain, stand before you. Until then, all the best.